Okay, hello chemistry students. Today we're going to discuss a very important topic, the greenhouse effect. We're going to use this computer simulation to make some observations. So first, let's look at the elements on the computer simulation. We have here a thermometer, and notice that the thermometer right now is reading a very low temperature, okay? We also have this green bar down here, which represents the Earth. Of course, the sky is blue. And we see in the legend here that the yellow particles are sunlight photons. This is visible light coming from the sun. And what we also notice, if we reset this, that what we have initially is sunlight particles, photons, visible light. They come down to the Earth. The Earth absorbs the yellow particles, the sunlight, and then emits heat. In order to relax, all molecules emit heat. Okay? This heat is called infrared photons. Okay? The longer wavelength than the yellow photons. It's what we think of as heat. Okay? Now, first of all, what is a greenhouse? If you don't know what a greenhouse is, it's simply a building made of glass. And the glass building is very good. It's very efficient at trapping in heat. And that way it's good for growing things inside that like it to be warm. Plants like it to be warm. Okay. So a greenhouse traps in heat. Right? So this is the greenhouse effect. We're going to use this simulation, which allows us to add in a glass pane. Okay. Now, if you don't know what a greenhouse is, it's okay, because I'm sure that you know what a car is. And I'm sure that you've observed that a car with the windows rolled up traps in heat very well. Okay? The sunlight comes through the glass, right? The glass is transparent to the sunlight. The sunlight comes through, as you can see, gets absorbed by the Earth, and then as the Earth emits heat, some of that heat makes it through the glass, but some of it, if you look closely, gets reflected back down to the Earth. It's actually absorbed by the glass and then re-emitted back down. It's emitted in all directions, randomly. Okay? But what happens is some of that heat accumulates. So you may have noticed that now the temperature has increased quite rapidly. Okay? We can add another layer of glass, and we can see that the temperature will increase even more rapidly, because you can see that there is even more heat being trapped. Now, the glass panes represent greenhouse gases such as carbon dioxide, CO2, or methane, which is CH4. So I'll give you a second here to look and make some observations. We can reset the simulation at any time. So let's do that now. And again, what we notice is that visible light comes down from the sun. It gets absorbed by the Earth. And the temperature remains fairly cool. Okay? It's not very hot. And when we add a pane of glass, like the windshield in a car, or like greenhouse gases, they're very good at trapping in the heat. And you can see that the thermometer, the temperature has increased quite rapidly already. Okay. We can add another layer of glass, or even another one, and you will see that a lot of heat is trapped. So this is what's happening on the Earth currently. At one point, before the Industrial Revolution, we had maybe just one layer of glass trapping in the heat. We can reset this and think about how that looks. So with just one layer of glass, a little bit of heat is trapped. And that's actually a good thing. Otherwise, the Earth would be very, very cold. And a lot of plants and animals wouldn't be able to survive. So a little bit of greenhouse gases is a good thing. Okay, but if we have too much, then what we notice is that the temperature increases quite rapidly. Now it's over, well, 100 degrees Fahrenheit. We notice that it's already up to 120 Fahrenheit now because more heat is being trapped in. So to review, greenhouse gases trap in heat. Okay? This is a good thing, but too much greenhouse gases trap in too much heat, and that has negative consequences, as we are seeing on the planet today. If we look at the thermometer now, we're already up to 160 degrees Fahrenheit, and that is not livable conditions for most plants and animals. So I've done a little review of how the simulation works, and I'll show you that we have a lab here. This is a student example, and I'm asking you some questions so you can take your own time to think about the questions. I'm asking you, have you ever observed that it's hotter inside the car than outside? Even when it's already hot outside, you'll notice when you get inside the car, it's much hotter. Why is that? And this student gave an excellent answer. The student says, it's hotter inside the car because the sunlight goes straight through the glass and everything inside the car absorbs that light, okay? And in order to relax, the molecules that the seat is made of, the steering wheel, etc., they emit heat. Okay? That heat gets trapped in by the sunlight, okay? And so what I'd like you to do is use the simulation to test your ideas, okay? And I'll show you in the simulation, there's also another page here that we can add in clouds. Clouds also act like greenhouse gases. In other words, they trap in heat. We can't see carbon dioxide because it's invisible. So we use the glass panes and the clouds to simulate the greenhouse gases. Okay. And you can see here that the clouds act in a similar way. The sunlight comes down, gets absorbed by the earth and the buildings and the roads. Everything that you can see absorbs visible light. That's why you can see it. But in order to relax, and everything in the universe wants to relax, molecules emit heat. You can feel it. You can feel it in your head. Heat is being released by your body. In the same way, heat is being released from the earth. Now, that heat maybe goes right back up into space. Some of these infrared photons, you'll see, they just go right back up into space. But you'll also notice that sometimes they interact with the clouds. And the clouds sometimes emit the heat up. The clouds sometimes emit the heat back down. And in this simulation, we also have a concentration of greenhouse gases. We can move this bar here, and it kind of makes it a little bit, you can kind of see that it changed. But really, we can't see CO2, carbon dioxide. It's invisible. Okay. But what you should have noticed is that the heat has definitely increased. Okay. And the reason for that is that clouds and carbon dioxide, all greenhouse gases, trap in heat. And this is the reason why the Earth, the atmosphere, the oceans are increasing in temperature, okay? Because they're absorbing heat and retaining that heat. So what we have here is a lab for you to work through. I have questions for you to think about. There's simulations. Each page has a link in the upper right-hand corner for you to click on And then you'll be able to work through the simulation yourself and discover what happens when greenhouse gases are increased in the atmosphere. Okay, so I'll give you some time to work on that by yourself, and I'll be ready to take any questions and work through this with you, whatever you need. Okay? Enjoy learning.